Hello, today I'm going to be talking about our 256 by 32-bit RAM. First I'm going to look at the block diagrams, and I'm going to look at our individual test benches for each component, and then I'm going to look at the total 256 by 32-bit RAM that we created. So, looking at the first level 0 block diagram, we can see that we're going to need 8 bits of an input address, we're going to need a clock, we're going to need a write read, we're going to need a 32-bit input, and we are going to provide a 32-bit output. So to create this, we have to look a little bit deeper at our level 1 block diagram. The three main components that we're going to need is we're going to need a 1-to-4 chip select decoder. This is going to provide a chip select to the second component that we need, which is 16 64 by 8-bit RAMs. And we're going to make this in a 4x4 variation. So each chip select is going to go into each column. Each column is going to provide their results to the third component that we're going to need, which is tri-state buffers. So we're going to have 4 tri-state buffers, 4 rows and 4 columns of 64 by 8-bit RAMs, and we're going to have 1x4 chip select decoder. So we all worked on these components together. Scrolling down, you can see the test bench for the chip select decoder works perfectly, as well as the 64 by 8-bit RAM works perfectly, and the tri-state buffer, which also works perfectly. I don't want to spend too much time talking about these individual components, because if they didn't work, the final test bench wouldn't work as well, and that's the one we're going to spend time talking about. So scrolling down to our top level analysis, I'm going to show you this view over here, which I got running on my computer. So to start talking about it, I want to explain that the left side of these red lines is the right portion of the RAM, and everything to the right side of these lines is the read portion. After I talk about each side, I'll show a zoomed in version of each. So on the left side is the right portion of the 256 by 32-bit RAM, and for this part we are going to have a read write of 1, which means it's going to take an input and it's going to put the input into the RAM, which is shown on the left side. Each value in binary matches the data input value in binary. For each chip select in the RAM rows, how I said before there was 4, 1 in each row, we tested 2 addresses to show that the right part, right as in actual physically right part of the RAM works. For example, addresses 00000000 coincides with a 32-bit data input of 000000, and an address of 01000000 coincides with a 32-bit data input of 01000000. So whatever the data input is going to coincide. If we look at the right side, which is the read portion, we are going to make the read write 0. Read write outputs the value, as shown from the right side. Whichever of the addresses that we input values into can output the value that they hold in the test bench by using the tri-state buffer. The read function of the 256 by 32-bit RAM works well, as you can see. So the next thing I want to do is I want to show you each side. So the first thing I'm going to do is I'm going to show the left side, which is the right portion, and the right side, which is the read portion, in a more zoomed in view. So this is the left side, the right portion. As you can see, everything works as we'd expect it to. And if you go down here, this is the right side, which is the read portion, and everything works exactly how we'd expect it to. That's our Lab 5, our 256 by 32-bit RAM. Thank you.